Hi guys, do we need a notebook for all the concepts we are going to code by side by side? आज ही तो आए हो यार. So, how are you feeling guys? कैसा लग रहा है? And welcome to the 4-day bootcamp of data structure and algorithm. So, I hope you have gone through the classes what I have done before. Have you? अरे यार, emotionally करने का. Okay, so I'll give some time for people to come in, and I'll give some time people to join in, and then we'll start. Or I hope you have gone through the videos I have done before, and I hope you have gone through it. You got the idea like what I do, how I do. And I'm a guy, I prefer that if you know things and if you are a fan of things for example, if you are studying something, you need to know to a point that you are able to solve questions, right? So the problem what people face is because of their no issues. That is not an issue. If you were not in there in the last session, I think I have gave the program structure what I'm going to cover. So it's what I will be taking today. So I gave you the program structure. Today we are going to cover bigger, then we are going to strings, and after that we are going to arrays. So these are all very fundamental, and they are very much required whenever you are solving a problem. For example, they give you either to reverse something, either to reverse an array, such kind of thing. And the notations, those are very important. And if you are from a computer science background, that is great. But if you are not from a computer science background, that actually doesn't matter. So the things I would be covering today would be a part of the complete syllabus. So it's not something you really need to focus upon. Like if I say there are theta notations and such kind of notations. So if there are those things for placements, they are not very much, they are actually not required, because this is how the industry works and this is how the placement works. So we have to focus upon placements, and our goal is to get placed. And thank you so much for joining me. Arey, itne log aa gaye yaar. Shit. I was not expecting these many people. Ab acha karna padega. Shit. I'm just kidding. So I'm a guy with a humor. So if you have any problem with any of the jokes or any such kind of stuff, you can always tell me. I got offended with such kind of stuff because, yeah, humor is kind of my thing. And let's get started. So in the last class, I guess I told you all about memory, what is memory, how memory works, why is memory there, why things are stored somewhere, why things are got out from somewhere. We did all that, right? But how many of you can tell me, if you know something about data structure, someday you learned something, somebody told you that there is big O. Somebody, do you know what is big O? You can just put it in the live chat and I'll know. Just tell me if you know about big O. Okay, yeah, this is the first class, and I feel there are many. So I guess let's get it over with, and I'll start. Yes, yes, exactly. You're right. I can see your comments over there. What about attendance? Arey, this is not college. This is not college, man. You don't have to give any attendance. You come here to learn about yourself. You come here to get your topics trimmed up, not something you really wanted to do on your own. So it's something you are learning. It's something you are learning. So right now I'm blind, so I can only see you guys and I can see my screen. So if there is something, and meanwhile I would be opening up the chat panel and I would be going through that. But till then you're with me, and till then you're with me. And today we are going to start with one of the most important thing, big O notation. What is the spelling? Big O notation. Okay. So I told you that I told you about the complexity. So there used to be complexity. If you don't know about complexity, all you need to do is just watch my later videos. It's on Skillenza's YouTube channel. So don't worry about it. It's not something I would be deeply confided into. So all you need to know is there are two kind of complexities: time complexity and space complexity. Time is very much equal to the I. For example, if I have this algorithm with me, and I'll be like, okay, algorithm run, and boom, I give a timescape to it. The algorithm is running. Okay, so this complexity over here, uh, the tool I have over here is going to measure it to 1 minute. So so my video is visible, right? तो वो सबसे खेल वाली बात हो जाएगी. Okay, so for example, I have an algorithm with me, and that algorithm is running. I'll just not show the video. I'll just show myself for a second. Okay. So this is something which represents time. Okay. And this is my algorithm. And this algorithm is running at some speed. Okay. Imagine that. And the moment it starts running, and the moment it is already there, all you need to do is you have to take how much time does it takes, like from going from here to there. Okay. Here to there. Okay, how much time does it take? The moment it starts, I'll be like, okay, I'll measure the time. Boom. And I'll see, okay, this much time this particular algorithm has taken. So this would be what? Time complexity. Simple. Then you would be wondering what would be the space complexity. It took some space, right? It took some space in memory, whatever memory we have. For example, if you take this keyboard, okay, take this keyboard as a memory map. So this algorithm would be this, for example, if this is a variable, it will be mapped over this keyboard whenever it would be running. So it would be taking some space on the keyboard itself, right? If I really wanted to put something, or if I really wanted to put something out there, it's going to take some space. And I'm telling it in a very brief, because in last two videos I have covered it. And seriously, don't panic if you don't understand this point. And hello, Ravi. Wait, huh? Me? Okay. So if you don't understand this point, don't panic. This is something which I have covered in last two videos, and you can just go and watch it. So you must be wondering, for example, a good algorithm. So how would we see that is if the algorithm is good enough, right? How should we know that? So for example, for a time complexity, it's how fast it is, right? How much lesser time it would take, the lesser time it would take from going one place to another place, the displacement, how fast it is. Space complexity is very simple. How much space does it takes? Okay. Very easy concept, right? Very easy concept. Like all you need to understand is how much faster it is going, how much space it is taking. Okay. So now you must be wondering that we should have some notation to it, right? We just can't say ki, okay, this is 10-second algorithm. We for example, interviewer asks, okay, what kind of algorithm would you use into it? Use that 10-second one, na? That takes 10 seconds. So the person will be like, what? So for that not to be there, for that kind of problem not to be there, what our great computer scientists and programmers did, they came up with notations, and that notation today we are going to learn is big O notation. Okay. Big O notation is a part of that, and big O notation is one of the most important notation out there, because you need to learn it, because interviewers ask that itself. It is how the industry has been formed. In every interview, big O notation comes because that case takes the worst case scenario. So for an algorithm to be rated, it is rated upon its time complexity. Space as well, but here we are focusing upon its time complexity. And which could be, for example, if you really want to run something, it could be 5 seconds, 10 milliseconds, something like that. Okay, some kind of random. If you're running anything, and if you're running a program on your system, it takes some time, right? It may be very short period of time, but it takes some time. So that kind of time we really needed to measure it. If you remember, if there are people who were in class 11, 12, and we had SI unit, remember? Why does I cannot remove a, so yeah. So if you remember SI unit, so this is going to be meter, this is going to be centimeter. They got a pole and they said like, okay, we are going to take this as a meter and it's going to be there. And we are going to put it in a museum in Geneva and we're going to call this as 1 meter. This is going to be called 1 minute. So that's how they came up with those conventions. Similarly, they came with the same convention with your time complexity. They were like, okay, let's break it down to that. So if you don't come from a math background, or if you don't come from an engineering background, sir, where is last 2 video of yours? Here only, man. Where will I go? where will I go? Your shared screen is not visible because I was not sharing screen. Oh shit! I was not sharing screen. So yes, so it's not something very important I wrote. It was algorithm. My algo would be taken into time complexity, and that time complexity can be 0.5 millisecond. For example, the time you take to open your Chrome, or it can be 10 millisecond, the time you take to open Android Studio. So that could be anything, right? So that program to run, that program, whenever it's running, some process is getting started, right? A process is getting started. Your computer gets to know, okay, the computer is like sitting like that, and you would come to it and you would say, App Store, open that. It'll be like, okay, App Store. I'll find that. I'll open App Store and I'll show it to you. So that complete process, it's taking some time, right? And for that time, we really needed to have something, a unit to it. And for that, let's take a very, very famous example. What could be a very famous example? Array. Okay, so I'm gonna teach array today. So let A be a array. Okay, A be a array, and the length of the array should be n. This is the length. People who don't know, generally we take n. The things we do, the stupidity we do in our mathematics, that everything should be x, y, z. Yeah, similarly like that. It's like that. So the length is n, and I think let's take all integers inside. So there are going to be all integers inside that array. Okay. Now, so they are going. So over that, I would have some programs. I would have some functions. I would have some programs that would be very treating this array in very different manner. So, for example, let's take Spider-Man. Okay. So I don't have a very creative feature for that, and let's call her Gobblewati. Yeah. So Spider-Man is our array. Okay, and this array, people can treat him like the way they want. Okay, he's not gonna change. He's with n length, and he is filled with integers. And Spider-Man to rich forever. Okay, why did I say it? So this is the array, and this is of n length, and it has all integers inside it. Okay, this is our main protagonist of the story. So this is person one, and this person one treats him in some way. Okay, either she is a very good person and she is a very good partner and she takes care of him. They are a very good partner. They go to every park, they go to every movie, they enjoy a lot. We have people like that in our lives, or if you don't, you'll have someday. So very joyful relationship they have with them. But there could be a different kind of people. So there can be this egg. Okay, so this egg treats him very badly. This egg treats him like actual Spider-Man. He says, okay, Joe, just go, jump out of that building. Just do that. Just do that. So every function is, there is a different function to it. And this is the same array. So I'm going to have 3 programs. I'm going to use some 3 programs for it. Let me see if I have any questions. Okay. So yeah, you're able to understand what I'm saying till here. Abhi tak you are able to understand what I'm telling over here, right? Because so I need a yes gang. So this is very I feel like I'm speaking to my computer, so I need a yes gang. Whenever you are able to understand something, or whenever you are able to follow, you just type yes, and I need 5 of those people. So volunteer yourself. मैं करूँगा yes. Just do that and just type out yes, and I'll be very happy. I'll be very happy because that gives me a pulse. So yes. So this is our Spidey and this Gobblebati, they are like, okay, this is how we are going to treat it. So this is function one. Okay, let's see how their relationship is. So their relationship is very good, and it's going on very great. So let's give it a name, F1. Okay, F1 on A. Got it? And what this is doing, this is 1 plus A 0. So I generally do it in Python. Python is easy for me. But if you want me to do in C++, if you want me to do in Java, I can do that also. So what this 1 looks like a 2. Yeah. No person has only 1, right? Yeah. So this is sum of the first integer. Okay. This is how Gobblebati is treating our Spidey. Sum of the first integer. Understood? And so then comes the egg. How does the eggs treat that particular person? So the egg is also not very bad person. And what does egg do? It takes F2. So math would be really important over here, and very simple maths. Very simple maths. Nothing like, we are not doing very great mathematics over here. And over here we are going to do sum A. Okay. And what is this? If you understand, sum of every element of the array. Okay. So I'm gonna number them. This is 1, this is 2, and third person. Third person, who could be the third person? I don't have a figure for it, but if you remember what kind of relationship Spider-Man and Iron Man has. Okay, so they have a very tough relationship. He treats him, if you have seen Avengers, so that person really treats him like, okay, you have to do something good. You have to learn things without your powers and everything like that. So he is pretty hard on this Spidey, and he's not like Gobblebati, or he is not like Jane Parker, that he's going to treat him very well, and he's not like that egg that it's a normal villain for him. So this person, this is F3. Okay, so what F3 is doing over here is, F3 is I would work upon my writing. I was working upon my writing, even drawing. So F3 is equals to pair. Okay. So what F3 is doing over here? F3 is pairing things. F3 is whenever it sees something, whenever it will create a bunch of pairs. So for example, our array could be 1, 2, 3. So everybody knows this is called array. Everybody knows that this is called array, right? So this thing is called array. Okay. So now whenever they are doing this, I have to come to it, right? Because like, yeah. So this is what is happening over in F3. How Spider-Man is treating our Spidey. He's saying that you have to create pairs. Okay. 1, 1, 1, 2, 1, 3, and it goes on and on. So 2, 1, and you know how this can be done very easily. This can be done with 2 nested loops. 2 nested loop is all you need to do this. So it is asking the algorithm to do that. So you see, different kind of people treating our array differently. The same goes with our mama, papa. Mama treats us differently. Papa treats us differently. Our sibling treats us differently. Why do they do that? So you have to understand everything through behavior. So this complete data structure and algorithm is only the behavior of code. That's it. Or kuch nahi hai. It's nothing very rocket science or very tough to understand. It's only the behavior of the code. And you have to understand the behavior of the code, right? So the moment you wonder, okay, so you understood till here. I didn't get a yes gang, yeah. Yeah, yes, I have a yes gang. And don't worry, guys, if you're thinking, okay, I don't know Python, what I'm gonna do. So chill, chill. Nobody is like, I'm gonna give you code in C++ too. I'm gonna give you code in Java too. Any language you want, I'll write that code. This kind of confidence you can have if you just practice much. Okay, so now when we are done with it, now when we come to the real deal. So the real deal is that we have an array A, and that array has some elements. Okay, and those elements are n elements. Understood? Understood? And for example, there could be different values of n, and then you have to check for different values of n, how my different functions, how my different code, or how my different algorithm is acting to it. So for example, take example. Okay, so would this example be good for kids? Chalo, let's take this example. Very bad example. You go outside, you have a couple of beers, and you're very tipsy. Okay, and whenever you're coming home, you're in a very good mood, and you're like, "Hello, mommy, how you are doing? Hello, papa, how you are doing?" So everybody will have a different reaction, right? So over here, you are the array over there, and your mama, your papa, and your sister or your brother, they are different algorithms and they are different code. So for example, if the code is that in what time would it take from your dad to slap the hell out of you? We have to calculate that time, and how much time it's going to take to slap the hell out of you for mom, how much time is going to take the slap hell out of you from your elder sister or your brother. So everybody has a different behavior to your doings. So if you are an array over there, you have some n, and everybody has some different behavior, and we have to track down that behavior. Now you must be wondering how this is big O, and now this guy is speaking about bears, and you have to relate things. You have to create a story in your head. That's how you're going to remember it. If you don't have a story in your head, you're not going to remember anything at all. Very sad, but yeah, it's so. For example, n is equals to 1, and these values can vary. So for n is equals to 1, so we have our first code. If you remember, ada. Okay, we'll go super zoom then. Yeah. So if you remember, our first code was, what was our first code? If you remember, yaad hai? Our first code was sum of integer. Okay, f1 is equals to a, and 1 plus a on the sum of the first integer. Okay, so if n is equals to 1, is it going to take that much time? Is that algorithm is going to take that much time? So you are very drunk, you enter the room, you enter your house, and your father is standing on the door. Will he take that much time to slap the hell out of you? No. So it's no change at all, no time. Okay. Then number 2, mama. So there is not very much difference in a father's reaction and a mother's reaction over the same thing. It can change over the time. But here pretty much instant, right? So we'll be like, yeah, pretty much instant. Now, your elder sister or your elder brother. So that person has gone through your age and is very close to your age. So that person understands. Okay, he just got caught. Now I have to slap him in the heat of the moment. I have to do it. So it'll take a few seconds when you calm off, and just to show your mother and father that he's also a very considerate brother and sister, and they'll slap you in some amount of time, right? Now, this was for n equals to 1. Okay, n equals to 1. So it's gonna be something what you did. So you're going to remember the story, right? You're going to remember the. Ye kya chal? Hey, don't see. You don't really have to care about languages, or if you really don't have to care about any of the languages. All you need to do is practice. And I'm always here to help you. I'm always here to help you. You can reach out to me on any channel. You can reach out to me anywhere you want to. So, and if you're comfortable in any language, you can start with that. Okay, you can start with that, because in my time, what I was doing, remember? So everybody in 11, 12 took C++ and everything. I was doing music. Dadun Tinta. Yeah, yeah, sad mistake. Yeah. So now the thing has now when we change the value of n, so over here you remember that n was equals to 1. So you were an array. There were three different functions and three different set of code. First, it's going to take no time. Second, is going to take it's going to be pretty much instant. And third, is going to take few seconds. So you have to take this into consideration as well. Okay, don't forget this stuff. Ki this is sum of integers. This is sum of every integer in the array, and this is going to be pair. So isme everything for this, everything's going to be this. Okay. Now here the game changes. Here the game changes. This was for n1. Up now we have to increase the amount. We have to increase the amount. So you did a mistake, which is n equals to 1000. Okay. So what you did, let's see what you have done. So you took your father's car and you drove it into a tree. Boom. And it was by accident. Again by accident, you did some accident. What's going to happen? Three algorithms are going to run. First, father. Second, mother. Third, brother. Okay, I'm going to name them. Father, mother, mother. So, and brother. Okay. So, three algorithms. What's going to happen? You're standing at the gate again, and you have done something which is now on the potency of 1000. So the number of units in your array has now become just 1000, and how they are going to react. So this won't change. This won't actually change. So this would be won't change. Now mother, who really understands that it is hard to drive, like it would be hard to drive, you were young or stuff like that. But then also it's your father's car, so it's going to be very instant. Now again it comes to your brother, that okay, how do I really act to it? It's going to take some seconds, and now your brother is very angry too, because it was your family car. It took some few seconds, okay, and it acted to it. So this is how the potency is changing, and this is how the behavior is changing whenever you're changing the number of elements in the array, right? Every program or every code has a different behavior to it. But what happens if you take your brother's bike and you drive it off the cliff? What kind of person would that be? But this is n equals to 10 million or a million. Okay, this is equals to what? 3, 6, 7. Okay, we are going to take this. This is 10 million, and the bike is in no repair condition. It is off the cliff. You live in Dehradun. You just can't find the bike, and it's already done for. Boom. N equals to 10 million. So similarly, how each and every program you take, for every program, it's going to be the same. So the father's reaction is very much same in every condition. He's either beating the shit out of you, or he's scolding you, or he's scolding you very bad. So over here, the father would be like very angry, right? The mother would be angry. And your brother, now your brother was taking time in responding. Your brother was the one who was taking time in responding. And over here, if you go by the program, if you go by the program, this is actually pairing. So this is actually pairing. This is taking time for understanding things, taking time to react on things. So F3 is over here is something which is taking time from the start. But with smaller values, it didn't have any problem. But something grave, something of very big value happened to it. What's going to happen? It'll take quite a lot of time to run, and it is not advised that it should run. We should not run this kind of thing because for your computation, it's going to take too much time. And as per your brother, he's going to kill you. But so it's something how you have understood the behavior of different program happening over an array. Understood? Understood? Now you must be wondering that why this guy told us the whole story about a family where you are just crashing cars, you are drinking, you are a very bad child, stuff like that. You must be wondering why. So you have to see over here like first, second, and third, right? So every these three has different speed, right? Had different speed of running. So that speed is something, would you actually come up and would you actually see that what actually defines the speed? So for example, this was done in 10 milliseconds. This was done in 15 milliseconds. This was done in 300 milliseconds. Okay. So this is how time has been proved out to be. So this is how time has been broken down into it. Now you have to always remember that the input is the most important thing. The input is the most important thing. For example, if you post a photo on Instagram, the input is a very large input, right? It's a image, it's a very heavy image, so their algorithm needs to run at a very high efficiency to treat that image into, so their server time would be very they make sure that their server time is very less, their processing time is very less. This is how you have to imagine things. So over here, if I jump the gun and I'll say the size of the array is speed of the algo. Okay, you have to remember this whenever an interviewer will ask you, okay, what is happening in that particular thing and what is happening, why it's not working in its best case. You have to understand that it is affected by the size of the input. Okay, so anywhere you code, in any language you code, see, coding doesn't matter. Yeah, see, the language, sorry, coding matters. The language doesn't matter. Right now I'm speaking in English. Okay, so you know English, you understand English. अगर अभी मैं हिंदी में बोलने लग जाता हूँ, तुम्हें हिंदी आती है, तुम हिंदी समझने लग जाते हो, क्या मेरी बातों का मीनिंग चेंज हो गया? हैज द मीनिंग ऑफ माय वर्ड्स हैव चेंज्ड? We say it in Hindi, the bhav, the the intention behind my sentence, has it changed? No. So similarly, Python is Python, Java is Java, JavaScript is JavaScript. You really don't need to worry about that. Okay, what languages? And take it from my experience, I wasted the first year of my college in choosing one language. I did that. I was very a kind of person who was like, okay, no, I'm gonna do Python, I'm gonna do JavaScript. No, I think let's start with Java. I bought a lot of books, I bought a lot of resources, I bought Udemy courses, Coursera, everything I could buy right there. But I understood one thing with experience, that all you need to know is engineering, how the behavior of a code changes whenever you do something. Language is always going to be language. It's plain simple syntax in any language you're going to write. So don't worry about it. So size of the input, very important. Always remember, this is going to be size of the input. Boom, very haphazard. Yeah, the size of the input is something which is on everything is really focused upon in bigger. So over here, let's for one thing for sure, I have jumped the gun. Size increases, time increases. Yes. So why I have such dirty brain? So yeah, time complexity is equivalent to space complexity. Yes. Time complexity is equivalent to space complexity. And so this is all. This is something you really not need to focus upon, or you really not need to say, I have to see it into the camera, and the light is blaring high. So not just the like speed of the runtime, also the size of the output. Okay, so speed of the runtime equivalent to size of the output. Okay, understood. So for over here, like if we really need to give notation for F1, F2, and F3, three cases, right? So for F1, the time notation was not very. Papa was slapping us every time, right? Papa was like, we are on the door, boom, slap. So not very important time signification. For F2, we had a smaller time significance, but for F3, it always took a large amount of time into some response or something like that. So let's break it down. Let's break the complete thing down in how much, for example, F1, how we are going to break that down is something which was always constant. So this is constant time complexity. Okay, what it is? Constant time complexity. So in future, we are going to do questions, and I'm going to speak like this. And you can always come back to refer to this video. But whenever we are doing question, this is how I'm going to write time complexity in. Okay. So as n increases, still the speed is constant. Papa has reacted in that manner itself, right? Whatever happened, he slapped us. Like what kind of person he is? He really need to think. But yes, Papa has done that. The forever we just came like that, and now it's mama time. For mama, ON, linear time complexity. Yes, this is how we write it. So this is linear time complexity. Okay. So I guess 7:38, man, I really need to increase my speed. So this is linear time complexity, and when n increases, what increases? Think of it. Like I really put a pause over here. If n increases, time also increases, right? And over F3, F3 is something which took too much time, right? Which took too much time, and over here O is n square. Yes. So this is why it's taking too much time. And if you remember, what was our code in? So if you remember what was F2. So in F2, to take sum of everything, it has to traverse it first, right? So traversing was going on. Every time it has to do it, traversing was going on. So this is the reason that we have broken down into linear time complexity. It's ON. And the change of the speed of algorithm. So you can, if you can just take a note of this. नहीं ये गलत फहमी change of speed of algo is equivalent to the size of the input. Okay, understood over here. And to understand why this is happening, to understand why we gave such kind of thing for every n. So there is a term, there is a very famous term, the behavior of these code, the behavior of these algorithm. To study that behavior, we call it as asymptotic analysis. Very fancy word, but ऐसा ही है बस, asymptotic analysis. Okay, this is what is basically used for this, and this is for Fn. If you understand differentiation and integration, Fn where n is tending to infinity. Fn on our function where n is tending to infinity. Okay, Understood over till here? Speed of runtime, speed or time. N is, so we have to focus upon time complexity over here. More than time is something which is very much consistent with the speed. किसी भी चीज, for anything to run, for anything to go on, the time complexity is taken in fair share. Okay, the time complexity is something we focus upon. Understood? This is all very much related to the time complexity. Like the thing you're only dealing with over here is the time complexity. Okay, you understood the change of the speed of the algo is equal to the size of the input of the speed. How does we take speed of anything? For example, my video coming to you, there is a speed, at some speed it's coming to you, right? And you can also change that in that. But on what factor it is very much focused upon? Time, samay, this. Okay, so the game is all about this time. The game is all about this time. So always remember that time is one of, either time is your enemy or either time is your friend. I'm a very big fan of time, the concept of time. So you must be wondering that why this guy is writing things in O1, right? So let me explain you. Let me explain you why do I have to write is equals to O1, and for our elementary operation, 1 is equals to A 0. This is a elementary operation. Okay. So what this elementary operation is doing, this is accessing single memory slots. So now you must be wondering, Prakash, you didn't tell us about what are memory slots or what are that stuff. So you need to a bit go back. It's on Skillenza channel. You can watch it. I have done it in a way that you'll understand. So whenever you're doing something, whenever you're doing an operation over thing, you have to access a memory slot to save it, right? So over here, what we are doing, accessing single memory slot. Okay, and after that it's going to take some time. Understood? Like it's going to, the time is going to be constant, as it took a single memory slot and it's going to be constant. So in back of the video I told that there are different kinds of memory, how we save it. So this operation is a 32-bit operation. Don't worry if I'm writing something like that. It's always, if I'm telling you something which is over here, it's gonna always be back there. It is explained, so just don't worry about it. And I'm always there to help you. Okay, so it's gonna take 4 elements. So this match I have told about this match, and this is first gonna read, and this is gonna access. Okay, understood? ये हल्का सा, this is going to be a bit if you haven't attended, just see through it what is happening over there, then I'll understand. And this is not very much be very much relevant to what I would be telling. So you must be wondering, okay, there are 8 element operations happening, right? So 8 element operations, why don't we write, oh wait, why don't we write that, right? Why this is like the analysis, how this asymptotic analysis, how is it this working? How this is working, like why I haven't written, why I have written O1 and why I haven't written O8. So you need to understand, if there is something which is not related to any part of the input, which is not related to in any way linked to the input, then we don't write it. We don't write in our notation. We will write O1. Understood? Understood till here? And whenever n is increasing, n increases, the array over here, it's still gonna take 8 operations, no matter what. No matter what, because this is our 32-bit operation, and n is increased, but it's still gonna take 8 operations. So for example, For example, your height is 5'7", and no matter how much you eat, you're gonna sleep on the same bed, right? ऐसा तो होता नहीं है. It doesn't happen like that ना कि oh I have ate too much, I will go sleep on the big bed. Like this doesn't work like that. The day you eat too much, you're gonna sleep on the big bed. You sleep on the same bed, right? So it's similar. So it's similar how you have to do it. And so over here, O1 is for constant time. Okay, understood over here. Now there are some significant factors you really need to care for. So we only care for significant factors which is affecting our input, because the game is all about input, right? The game is all about input. Right now you're getting input from me, right? uh, I guess sir, F2 change speed, or I'll just come to your questions. If the size of array increases, there is no relation with program complexity. So in first question, right, I just told you, what you are not able to understand. Sir, F2 and F3 both cases can change speed of algo is proportional to the size of input. Yes. Yes. Okay, I'll just redo it again. I'll just go do a small redo again. So over here we had different. I'll just give you a sum up. So we had F1, F2, and F3. Understood? F1 was the sum of integer. Okay. F2 was the sum of every element of the array. Understood? F3 was pairing of the elements. Easy. Now, after that, we had this array. This array could be of any size, right? I just made you understand this array could be of any size. And now our F1, F2, F3, how they are behaving to this array size. So for example, F1 is taking no time. F2 is taking no pretty much, it's also instant. As F3 is pairing, as it's traversing and then pairing, it's taking few seconds. Dhire dhire we are increasing the size of the array, right? This is basically the size of the array. This is what? The size of the array. Okay. This is n is the size of the array. And whenever you are changing the size of the array, it's what is that? That is the size of the input. यहाँ तक समझ आया? ये सब size of the input थे. This was all the size of the input, and we really needed to speak in terms of time. Ab now here we have to put it over the time complexity. We are focusing upon time, guys. We are focusing upon time. The moment we change the time complexity of anything, its speed's gonna change. Understand that. And the size, like I told you, the size of the array is directly proportional to the speed of the algorithm. So you have to see that the size of the input is directly proportional to the speed of the algorithm. Okay. And time complexity and space complexity is something which is balanced upon, which is very much the same thing, because the speed of the runtime which comes inside this, okay, is pretty much equivalent to the size of the output. जहां तुम्हें समझ नहीं, the moment you are not able to understand anything, why you give more real example? Can you give a more real example for pair? So what is happening in pair? Pair mein, if you understand, there was a time we used to do 1:1, 1:2, 1:3. Remember? 2:1, 2:2, 2:2, 2:2, 2:3. Similarly, this is pairing. This is pairing. This is how you are pairing numbers. This is not very, I guess, not very hard to understand. See, कितना अच्छा टीचर हूँ मैं यार, मैं वापस आ रहा हूँ. So now coming to the point where you are not able to understand. Okay, so F1 at O1, this is constant time complexity. Okay, because it's not very much cared upon, but it's not very much focused upon. Whenever we have 1 over there, O is O is equals to 1. We are focusing upon why the constant time complexity is the same, because it's not changing however we change the size of the input. Agar, for example, if I drink this, no change is going to happen in me, right? No, it's going to be the same. So the time is going to be constant over here. N is increasing. N is increasing. First, I had this energy drink with me. After that, I had this big bottle with me. The N is changing. The N is changing from over here to here. But the speed of myself is going to be constant. This is constant time complexity. So this is for F1. Why it's for F1? We need to really go back into, because it is only a sum of integer. It's not very hard to do. Sum of the first integer, it's not very hard to do. So it's not changing in that way. And you must be wondering, Prakarsh, how did you decide the complexity? It's something which will be given to you. Now, after that, I would be coming on a graph. It's going to show you how to understand the complexity of anything, how to take out the complexity of any program. So I'm going to come to that. Just don't be ghabrao mat yaar. Just don't be scared. I'm there with you. F2ON. So this is linear time complexity. Okay. So over here, as n is increasing, over here the n is increasing, right? So the n is increasing to a point. It's linearly. I'll draw a graph as well. Okay, so it's increasing linearly. For example, in some way it's increasing. Okay, for increasing n, there is also an increase in time as well. There is also, if there is n increasing, there is also increase in time as well. Understood? So when n increases, the time increases. Now you must be wondering how on F3 O n square has come to a point. Okay, so when there are very large input, or for example, there are time when there is everything is considered upon the input and the running time as well. So that is something, for example, if I have n into n with me, O n into n, this is going to come in time. So see, you are not going to able to understand in just one go, because this is a very vast topic. But I'm trying to cover it on a very slower pace. Or if there is something you're not able to understand, I'm always there with you. So don't be scared. Don't be scared. I'm there. Okay. So you have to understand the change of the speed of the algorithm is equivalent to the size of the input. I guess I have to go back to the comments. Okay. 8 variable thing. I'm gonna. ये मैं आगे भी लगा लेता हूँ. So 8 variable thing. Bhai, 8 variable, why you haven't come in the last class? So you had to. So this is how memory is saved. This is how memory is saved. This is how the complete memory is saved. Like in memory, you have to come to that video. I'm gonna just open that video and show it to you. Where you can find that video. See, you really need to go back and you really see. This is my first class, and this is my second class. So blue one, the black one. Over here, I have completely explained how memory is saved and how memory works. Okay, so this is how I have told. This is how memory works. Okay, so you have to go back to it. You have to just watch it, and if you are not able to understand, I'm always here for you. I'm gonna help you out. Okay. Zishan, we are coming to that. So, and we just did over here, and after that, the behavior. Now the change of the speed of the algorithm. Okay, so behavior of a function is directly equivalent to the asymptotic analysis. Okay, and where n tends to infinity. The output can be anything. The output can be very large. Okay, so see, you have to understand, we are just in 54 minutes of our class, and it's a bit tough for me to just go with everything, and you have to come and revise with what I say and what I do. Okay, so this part, this part is something which I'm going to take care for you, and I'm going to explain it to you in a brief that how this is happening. Okay. So this is on me. I'm gonna actually explain it to you, and I have explained in the last video, and you'll be able to understand it. Okay. Over here, so you just focus upon this part. Okay. When n is increases, there are only 8 operations happening. So this is we are speaking for the f1. Okay, we are speaking for f1. Whenever n is increases, only 8 operations is happening. So it's all gonna happen on constant time. N कितना भी बढ़ जाएगा operation, n how much n increases, the number of operations gonna be 8 operations. So it's gonna be constant time. And so we have to only care about these significant things. So for example, if I take something in which I have f1, f2, f3, and this is equivalent to f4. Okay. Now you must be wondering, ki, Prakash, what are you doing? Why it has come to this? So over here, for example, O n square, and don't be worried about it. I'll explain how this has happened. O n plus O1. Okay, this is a complete summation of this. Okay, so this would be written as f4 would be there, O n square plus O n plus 1. Now n is tending to infinity, right? N is tending to infinity. Now n is tending to infinity. So something which is this small, should it be called significant? Something which is this small, n plus 1, should it be significant over n square? If you remember integration, if you remember differentiation, would it be significant, or would it be insignificant upon this on square term over here? Would it be that? Think, and you can ask your questions. Sir, if the size of iron is directly proportional, that means so you can answer. Give some examples too. Okay, I'm gonna give some examples. So over here, you have to see that f1, f2, f3. So you have to come to a point that you have done these 3 things. So over these 3 things, what are parents gonna remember? Just think what your parents are going to remember. Are they going to remember you coming drunk? Are they going to remember you crashing the car? Or either you're going to remember that you thrashing your brother's bike forever? Because n is over infinity, your amount of mistakes are over infinity, and these are one of the biggest things you have done. So this was coming drunk, thrashing the car, and losing the motorcycle. So the losing the motorcycle would be very greater over there upon those 2 mistakes. So O n square is always going to be significant, and these 2 mistakes will be forgotten. They will be forgotten because you have done something insignificant, so something significantly so big that those 2 things they can seem insignificant now. For example, this lockdown was very significant over the period of time, but right now people have lost, over the time period, people have lost the significance of coronavirus. Do you think of that? Do you think of that as an issue? That now, at that time, where a packet of whey bread was very important to get to, now it has become very insignificant, because you can just go out there and buy a whey bread. So over the period of time, it has become insignificant. But the coronavirus, or n square, and you must be wondering, ki I made it n square. So just focus upon, I have not made it n. I have not named it out of nowhere. I'm going to explain why this is O1, On, and On square. So On square is a numeration we have given to it. We have given to it. We haven't found from it. We haven't done any kind of a research, or haven't written any piece of code to understand that this is going to give On square. Understand that as well. So after that, so this would be your significant answer. Okay, it's already 1 hour. I guess I have to increase the timing of my classes because in now, so this is how you find the constant factor and this is how you do it. So for example, if this complete thing becomes O2n square, do you think what would be it changed to if n is equals to infinity? The same is going to be changed into O(n) square. And guys, if you're not able to understand this in English, because there were many people who really gave me a request that I should do in English, you can come to the Hindi session as well. If you're not able to understand, see, for me, it is my job to teach you guys. It is my duty to teach you guys. And I can do it in English, I can do it in Hindi. So whichever language you are comfortable with, you can always ask for that. You can always so because of your requirements and uh, because of your request, we have actually started this to do this in English and Hindi as well. I speak a bit of Hindi in between. Sorry for that. Yeah. So I'll tell you how many types of big O notations are there. Okay. So it'll be very easier for you to understand in future or in upcoming time that how many logarithmic or type of notations are there. Okay. So this is O1. Okay. Now I'll give some space and I'll write O(n) square. Okay. And O(n), I'll give some space, O(n) square. You must be wondering why I have given space. I'll explain you that. And now, okay, so these are one of the most important factors. These are the most important notations you really need to know. Now, after that, you would be reading in some books and there would be in some algorithm, there is O log n. Okay, this is logarithmic time. Here the time is logarithmic. Okay, and over here on cube on to the power 4. This is how it is being followed. Okay, and now the worst one is on factorial. Okay, so these are the ways that you can represent an algorithm. These are the ways you can represent an algorithm. Now you must be wondering, how do I come to a conclusion that this algorithm is on, this algorithm is O1, this algorithm is on cube, or how is it that happening? So for that, you need to come to the next class and I'm going to give you an homework, a small homework you have to do, and you have to tag me, and it's a very small homework for the top five algorithms or five algorithms you are comfortable with. You have to find what is the big O notation for that algorithm. It's not very hard job to do. All you need to do is use Google, but you really need to think. And when you do it, whenever you do it, you really need to plot a simple graph in that it would be represented. You can draw it over a piece of paper, you can draw it over anything, and you need to tag me at the rate Prakarsh Pathak 0 and at the rate Skillenza. You have to tag either of these, and we would go through the solution and we would see what we can do for you, something special we can do for you. So you have to focus upon that. So these are the type of algorithms. I think I forgot one. O1, O log n, O n log n. Okay, so these are the only type of notations you really need to focus upon. In the next class, I'm going to teach you how to find that big O notations for different algorithms. So always remember that always the worst case scenario of any algorithm is considered. Nobody cares about the best case scenario. So these are the things which are required to find out the worst case scenario of an algorithm. Why? And whenever an interviewer is asking you a question, you have to ask the interviewer, are you asking this for an average time, or are you asking this for a worst case? Okay. Always remember, and whenever you're solving a competitive programming or dynamic programming question, you have to focus upon this. Understood? We have just gone too much over the, not too much, but we have after some. Yes. So if you have any doubts, I have given my handles to you. You can ask the questions in the comment section too, because live chat disappears as if I'll end the video. So you can ask me questions over Twitter. You can ask me questions over LinkedIn. You can ask me questions over any Skillenza handle. If you have any question, you can tag me and you can ask me that. And please tell me that how was the class? Did you like it? And what kind of changes would you want in the class? If you really want me to open the terminal, because that comes later. Okay. First, you need to really need to understand the concept behind it, and that will come in later time. Okay. I guess that would be it, guys. Thank you so much for joining in. Bye bye.